Hello students, welcome to Young Cubs. We are again continuing with the same chapter describing sequences. Our eighth sum says, two students, Ruth and Ricardo, are discussing the following sequences. These are the positions and the terms given. Alright. Ruth states that the rule for the nth term is simply to double the position number. Let's work out Ruth's nth term rule. So Ruth says to double the position. Position is denoted by n. So does that work out? So 2 into 1 gives me 2. Yes. 2 into 2 gives me 4. Yes. 2 into 3 gives me 6. This 1, 2 and 3 this is the first position, this is the second position, this is the third position. What does doubling a number mean? Doubling simply means to multiply it by 2. So yes, her rule looks correct. Ricardo says that another rule is just to add the position number by itself. So 1 to be added by itself gives me 2. 2 as a position to be added by itself gives me 4. Look here. 3 to be added by third position added by itself, which is 3, gives me 6. Yeah, so even he is correct. So the position number needs to be added by itself. So even his rule is correct. So what will you write? They both. So it says who is correct? Justify. So they both are correct. Yes, children, as 2n is equal to n plus n. So it's the same thing, repeated addition. Alright, let's move to the next part. So that's just one, there's no sub part of this, there's no ABCD of this. There's the next sum directly. Only 2 terms of a sequence are shown below. Okay. So, which is first position has 3, second position has 6. Okay. So, which of the following statement is true? The rule for the nth term is n plus 2. So, n plus 2 means the position plus 2 gives us 3. Okay, this is good. Then a second position plus 2, which gives me 4. So here it is 6. So this is not matching. So yes, we cross out this one. The rule for the nth term is definitely n square plus 2. So n square is 1 square plus 2, which gives us 1 into 1, 1 plus 2, 3. That's my first position. My second position, square plus 2, which is equal to 2 2s are 4, 4 plus 2, 6. Yes, so it could be this one. Correct? But isn't there another rule? Isn't there another rule? However, I could also multiply the position by 3. So 1 into 3 gives me 3, 2 into 3 gives me 6, 3 into 3 could. So I am not sure if this is the only rule that could be applied. So the rule of the nth term is definitely n square plus 2? No. It could be another one as well. So the definite rule for the nth term cannot be worked out yet. That's my answer. Why? Because we need more terms. We need more terms to identify a definite rule. So justify your answer. my answer is the rule for the nth term cannot be worked out. The rule for the nth term cannot be worked out because more, the definite rule, let me put this, children please, that definite rule for the nth term cannot be worked out because we need, or rather more terms are needed. Yes, children? Okay. What's the next one? Oh, we have the next sum directly. Okay. So, in the previous exercise, you saw the following sequence of patterns of white and red squares. Yes, we've done something like that. But at that time, the sum asked us to calculate the term-to-term rule. Right? So, let's see what's different here. Copy and complete the table of value. Okay. Copy and complete the table of values. So, number of white squares in the first position. So, it is 1, 2, 3, 4, 5, 6, 7. So, white squares 7. Second pattern 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. So, if I go as per term-to-term rule, my next answer should be 16. However, I will not write the answer because right now we are doing sums on position-to-term rule, or we are doing nth term. So, we will find out the value of the fourth position using the nth term. Okay, now it says they want the number of red squares too. So 1, 2, 3, 4, 5, 6, 7, 8. First is 8, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Next one is 10. Third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. This as well we shall find out with the help of position to term rule, which is nth term. Alright. So here our table is yet not completed. We shall complete it. Write a rule for the nth term for the number of white squares. So looking at referring our table. Okay. So what is the formula that we need to understand? So our first term is 7. That's the formula that we are going to use. Tn is equal to a plus n minus 1d. Correct, children? So 7 plus 10 is 3. 10 plus 13 is 3. So our difference is 3. Our first term is 7. So with that information, let's work this out. So Tn is equal to a plus n minus 1 d. A was 7, n minus 1. So we have to find out a rule, write a rule. Difference is 3. So 3 multiplied by n, 3n. 3 multiplied by minus 3, minus 1 is minus 3. So 7 minus 3 gives me 4 plus 4. Yes, so that's the rule that works out for the nth term rule that works out for the white squares. Alright, with reference to the pattern themselves, justify why a rule works. So now I will work out my fourth position. That will help me justify. So again, what was the rule that we got? We got 3n plus 4, correct? My rule is 3n plus 4. So my fourth position, so T4 is equal to 3. Fourth position, 3 4s are 12 plus 4 is equal to 16. Yes, so check, verify if it fits into the term to term rule as well. It's a +3. Yes, and this works good. So have I justified this? Yes, the central block. Okay, so I'm going to write it in words. Okay, so I'll write the central block, CENTRAL, central block. Which is the central block? This one, this part. Here there was 1 column, here there are 2, and here there are 3. Yes, so every time a column of 3 gets added, so the central block of white squares is 3n, which is this bit. Yes, and then what happens? 3n, then there are always 4 corners to add on. Yeah, so that's how you will justify your answer. Okay? Okay. So now with this set of information, what was our white tiles rule? The rule says predict the number of white and red squares in the 85th position. So children, here we have worked out for the white tiles, correct? We haven't yet worked out our rule for the red tiles. So here we work this out. So a plus n minus 1d. So a is how much? Here for red tiles it is 8. So 8 plus n minus 1, and the difference I remember is 2. So 2 into n gives me 2n, 2 into minus 1 gives me minus 2. So 8 minus 2 gives me a positive 6. So 2n plus 6 is the rule. So now they want us to find out or predict the number of white and red tiles in the 85th position. Rather, children, see, it can be worked out separately and it can be worked out together as well. So I'll show you how it works out. So in the first position, how many squares do we have in total? So it's 1, 2, 3, and it's 1, 2, 3, 4, 5. So 3 5s are 15 tiles in total, red and white. Okay, here we have 1, 2, 3, 4, 1, 2, 3, 4, 5. So 4 5s are 20. Here we have 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So we have 25. So what's the difference? Okay, the difference is of 5, and our first term is 15. Yes, so yeah, so what is our term to term rule going to be? So a plus n minus 1 d. A is 15, n minus 1, difference is of 5. So 15 plus 5n minus 5, which is equal to 5n plus 10. That's the rule for a combined rule for both. Okay, so term 85 is equal to 5n plus 10, which is equal to 5 into 85 plus 10. Correct, children? So 5 into 85, 5 into 85 gives me 425 plus 10. Answer is 435. Alright, so this is a combined figure, combined amount of tiles, but in case if they want it separately, okay, you could work this out separately as we have the rules. So T85, this we are going to do for white tiles. So T85 is equal to 3n plus 4. That's what we had got as a formula for white tiles. 3n plus 4. Correct? So 3 into 85 plus 4, which is equal to 255 plus 4, which is equal to 259. White tiles in the 85th position. Correct? And if I have to work out the red tiles, so 285, my rule was 2n plus 6, which is equal to 285 plus 6, which is twice of 85 is how much? 170 plus 6, which gives me 176. So here we have calculated both ways, in a combined way as well and in separate amounts as well. That's all for today, kids. Thank you and God bless you all.